In this first 2-3 video, we will look at examples 4 and 6, and they are very similar directions. We're going to describe the transformations of the parent graph to obtain the graph of g of x, and then the directions tell you to graph by hand and then check your result with a graphing calculator. So, as always, we're going to compare what we have to the parent graph x cubed for this case because we see a cube. And obviously, the first thing we notice is that we have a 2/3 multiplier, or an a of 2/3, which means that we're going to have a vertical because it's on the outside, and it's a direct effect, so it's a shrink. Fix that K. Shrink by 2/3. And then we can, and I'm okay to collapse these two statements you could make about the vertical and horizontal translations into vertex and put that in quotes because it's obviously not really a vertex for a cubic graph, but the vertex gets moved to the right 3, so we have a positive 3 and up 1, positive 1. So we're going to take this graph, which would normally start at the origin, and we're going to move its starting position to 3, 1. So we're going to go to the right 3 up 1 and plot our center point, and then we're going to go to the right, and from our center point, or our air quote vertex, we would go to the right 1 and up 1. Now we're going to go to the right 1 and up 2/3, which puts me there. And then because it's a cubic parent, we would normally go to the left 1 and down 1, but we have a vertical shrink by 2/3, so we're going to go to the left 1 and down 2/3. And then for the parent graph, we would go to the right 2 and up 8, but we're going to go 2/3 of 8, so you can think of that as a multiplier. So 2 times 8 would be 16/3. And 3 goes into 16 5 and 1/3 times. So we're going to go to the right 2 and up 5 and 1/3. So that would put me somewhere right about, let me try that again, it didn't make the mark. To the right 2 and up 1, 2, 3, 4, 5 and 1/3 is right there in that neighborhood. Alright, and then I'm going to go to the left 2 and down 5 and 1/3. Should be about right there. And then I trace my curve out to look like a cubic, but targeting those points. You should always go out as you go up. Your graph should never go vertical, and it should never turn in on itself. And actually, my last part of that was not so pretty, but you want to, I would rather you risk making it go out too far, but it shouldn't do any weird like bending suddenly. It should be a transition out very gradually. And that is number 4. So for number 6, we're going to use the same idea, but now we have a 4th degree function, so the parent would be a 4th degree graph we would compare this to. So this one is going to look somewhat like a parabola, but flatter in the middle. And so our first step is to describe how this graph would be different. And again, the first thing we see is that 3, and it's outside, so it's direct and vertical. So the first change is a vertical stretch by 3. And again, I will let you use our little twittyism, if you want to call it that, of the vertex notation, although this one actually would have a vertex. So our vertex, which was normally at the origin, is now moved to the right 1 and down 2, because the inside's backwards, outside direct. So we're going to move our vertex from 0, 0 to 1, negative 2, which puts us here. And then we are going to go where we would normally go to the right 1 and up 1. Now we're going to go to the right 1 and up 3. And then we're going to go to the left 1 and up 3. And then if we went to the right 2, 2 to the 4th would be 16, and we don't have enough steps above a vertex to go all the way out there. But when you draw a 4th degree function, it should be a little flatter in the bottom, and don't go crazy with it, but especially on one where you have a stretch factor of 3, it's going to be less obvious. This is going to look a lot like a square when you have a large stretch factor. I don't really like the way that looked. Fix that. It's a little better. Alright. Actually, the left side's bothering me a little bit. Now the right side doesn't match. And I'll let you see me making these like repeat attempts to help you see the fact that you don't have to get this right on the first try. You can keep playing with it until you get it to look like you know it's supposed to look, because this is a part of your answer when you make the graph. So there's the graph of number 6, and that's the end of your first video for 2-3.